Hello, friends. We are back with episode 229 of the R Weekly Highlights podcast. This is the weekly podcast where we talk about the excellent highlights and other resources that have been shared on this week's issue of R Weekly, which you can find at rweekly.org. My name is Eric Nance, and I'm delighted you join us from wherever you are around the world. And, it's a Friday recording again for us, but luckily my co-host is right here, Mike Thomas. Mike, how are you doing today?
Doing pretty well, Eric. These warm summer months and the upcoming World Cup are making it a little tricky for me to make sure my light is staying green on whichever internal Teams Slack messaging service you use. But I'm doing my best.
Yes, that's right. It's hard to believe it's finally almost here, and there's going to be a huge influx of fans across the world coming to the North America sites here. And are you going to any games yourself, or are you just going to be watching?
I was kind of waiting for the ticket prices to crash, which they're starting to a little bit.
Oh,
So we'll see. I'll keep you posted.
nice. Would be. I know some of my colleagues at the day job tried to get on that. Was it luck lottery type system? They were not so fortunate. So one of them is just going to be watching and see what happens. Maybe they'll get tickets later. But for those of you who are going to enjoy the World Cup, have fun. Yeah, that's going to be a good time. But we're not going to be kicking balls around here. We're kicking around awesome highlights of the R language in our weekly. So, as usual, we have a curator every week. And this week is Jonathan Kitt's turn for our curator team at our weekly. And as always, he put together a fantastic issue here. And he had tremendous help from our fellow R weekly team members and contributors like all of you around the world with your poll requests and other suggestions. I am one of those people, Mike. You've heard me say it before. Those that have listened to my, previous back catalog and my previous podcast know this. I like to use R for all the things. Yes, I know it's got this reputation of being statistical computing, and of course it is. But it is a programming language at heart, and you can do practically anything with it. And in this one, the tagline that came through when I saw this issue definitely had those vibes, and I wondered, what is this really all about? Well, we're going to have some fun with this. This post comes to us from the Lander Analytics blog, and it has been authored by Gus Lip. Well, crap, I butchered the name. Where is it again?
Gus Lipkin.
Yep. It has been authored by Gus Lipkin, and it is literally called Building a Computer in R. Now, as someone who literally just built a new server a couple of weeks ago, I bought it, okay, but you get my point. I was like, well, okay, what do we have here? So, Gus talks about kind of the genesis of this, and he met a very talented engineer from Posit, Emil Fittfeld, who has been huge in the tidy model space and the Chordal space, and getting talking about some fun puzzles that they were working through. And somehow it goes to, what if you can use the R language itself to literally build not just programs in R, which of course we all do with the R language, but to somehow get it as lowest level as possible to somehow replicate an assembly style set of programming. You may be wondering, what the heck are you talking about? What is assembly? Well, when you're using a computer like Mike and I are doing right now to record this podcast, or you're coding up R code, all the fancy interfaces like R, like your web browser or whatnot, all get translated eventually to some kind of machine code that your computer runs. That's the assembly code we're talking about here.
Ones and zeros, baby.
Ones and zeros, it's binary bits all the time, man. And I still remember one of my favorite characters in the Tron movie was Bit, and he could only answer yes or no. There you go. But what we're talking about here is, what would this actually look like if we kind of turn R into this assembly-like infrastructure? So this goes pretty deep here in terms of the concepts, if you want to mirror the computer science lingo that you may have had in a computer science course. But Gus talks about two main operations that they want to build in what's called this instruction set. And they keep it simple for the purpose of this blog post. One called add ry, which adds a specified number y to what's called a register, which is in that r placeholder, and also sub or subtract ry, which is subtracting the y from that register. So when you write a program, you're in essence making maybe a sequence, an order of these kind of lower level instructions. And then in the end, you get the final value after however many intermediate steps that are done in these registers, if you will, and you will see them reported back to you. And the way that he's going to report it back is a handy function called int to UTF-8, which will give us kind of the clarity on how to do this or how to interpret this. And he wants to do this in a virtual machine kind of setup. So what do you need to do that? You need somewhere to store the actual state of these registers. You need the functions, these instruction functions like we just talked about, and you need something to actually orchestrate all this. If you're dealing with LLMs, you might be thinking, oh, you need an LLM agent driver, right? No, this time we're talking about the CPU, the master control, as they say. That is what, in practice, in your computer, is driving the actual execution of these instructions. So, at a decision point here, what framework do we choose in R to kind of give this flexible system of instructions with, flexible inputs and outputs? He was debating between two choices here in the object-oriented paradigm, R6 or S7. S7 is the newer one that we talked about last year or so, as kind of this merging of concepts from S3 and S4. But he decided to talk about R6. Why did he go with R6? Well, in S7, those objects that you construct, they don't necessarily change it. They just make a copy of the original. But with R6, you can actually change the original object, but you're not necessarily needing to assign that to anything to make that change. Hence, you don't really need this copying mechanism. And in his opinion, more replicates what a CPU might do. So with that said, it's R6 time. How do we do this? First, creates the registers themselves. Again, he's using this object, this function UTF-8 to int this time to translate a 0 into this kind of machine readable number. And then the registers are a list object, and he assigns A, B, C, D, E to separate instances of this register. And that gives us a set of integers. And technically in the byte language of what we're talking about assembly, that's 48. No other classes, nothing else done there. Step 2 now is to make a list of functions that we alluded to earlier, add and sub, that will basically carry out in R6 what you would do to that object, i.e. with a self-reference, add an integer y or subtract a number y, something like that. And then step 3, give it a little bit of help. They call it the supporting materials. And this is more about, kind of metadata approaches to this, giving it an identity, giving it a call to run this operation from the register, I should say. So he's got one called call and one called run. That run will kind of be like the CPU of sorts, orchestrating the operation with a clever use of while and other infrastructure ideas here. And then you put it all together into R6. So when you start an R6 class, you use the R6 package with the R6 class method or function itself, give it a name, give it the public methods, where he kind of does this list operation to take all these different calls and this run, anonymous function, and then a private method, which you don't have to do, but it's kind of like an increment in this case. Just kind of every time it's invoked, it's going to increment a counter by 1. And then you can run it. So he makes this list of vectors where they have the function that he wants to run called add or sub, the register, which is one of these letters, A, B, C, D, or E, and then the integer, which might be 76, etc. It makes a new object from this computer R6 class that it made, and then it just runs it. And then after run returns, you get then an integer, but you can get the letters back out. And he spelled out R6 CPU. That seemed kind of magic, but if you look in the blog post, you see where the letters land that he did for A, B, C, D, E, the actual points and kind of the numeric indexes. And it's actually pretty clever. But I can't believe this actually works, part of me, to be honest. But as you can kind of tell, we didn't actually build a computer with this. This was a very clever introduction to R6. R6, if you do not know, is the underpinnings of a lot of the packages Mike and I use on a day-to-day basis, like Shiny, like even for testing Shiny Test 2, and many others. It is extremely powerful. I've delved into making my own R6 classes, and it did seem like a lot to chew on at first. But I think this is a pretty novel way to learn it. And as we say, with these kind of structures in the R language, you can build some pretty sophisticated packages or interfaces to accomplish some really nifty things if you like object-oriented programming. So very clever posts. They had me hooked. And I don't pretend that R is going to build my next CPU, but it's great to see what that mythical world could look like with a little help from R6 here and there.
Couldn't agree more. It's always kind of fun to see these blog posts where we push the boundaries of what's possible in R. I've actually had the chance to work with Gus before, and he's absolutely brilliant. So it's great to see this blog with him kind of doing exactly that, pushing the boundaries of R in a really clever way. And it's a good reminder, as you mentioned, that R is not just for statistical computing. You know, it is a fully Turing complete, I think, as they say, right? Programming language.
You got it.
Where we can do a lot of fun things. And R6 in particular is, as you mentioned, you know, underpins a lot of the packages that we use. Shiny, the Waiter package by John Kuhn.
Yes.
I have to imagine a lot of the API related packages, maybe like Plumber, maybe Hitter even as well, may leverage, you know, some R6, S7 style object-oriented programming. Don't quote me on all that. I haven't done my full research, but there's a bunch out there. Let's just put it that way. And, you know, the interesting reason for that design choice, Gus leveraged R6 as opposed to S7, as you mentioned, is because R6 objects are mutable. They're able to be changed in place, as opposed to S7, where that returns a copy of the object with changes applied and a little more overhead. So that you, in contrast with R6, you know, you can have the state change without needing to reassign the entire, you know, hardware variable every time, if you will. And that registers convention, that named list of integers and the instruction functions that he laid out, like add and sub, kind of confusing to take a look at just kind of on their own. Right. But the narrative around it and the way that Gus lays it out explains it beautifully, as he kind of builds those standalone objects first and then splices them into an R6 class using that unlist, which makes, you know, the code highly, you know, modular and testable. And the result is super cool in the way that the VM kind of uses a clock and an index or a program counter and a loop to execute the instructions that eventually spell out R6 CPU, the grand finale, by converting those register integers back to UTF-8 characters. And again, you know, just demonstrates that R6 is the right tool for modeling, you know, abstracts with identity and state over time, things like Shiny sessions, database connections, simulations. So really cool walkthrough by Gus, and this was a fun one to read this week.
Yep, and it's definitely on brand with the organization he works for, Lander Analytics, as I know Jared Lander himself has used R for many operations in his conference talks. So, but again, I think the fundamentals here, getting comfortable with object-oriented programming, and even more generally, list objects are so important in my workflows. Getting a good handle on how to wrangle them, how to maybe, you know, unlist things or wrangle them together, maybe concatenate them together. Lists are one of the most fundamental object types, because when you use R, especially with these API services. So if you use like a package in R that wraps an API service, that JSON that comes back is often coming back as a list. So having that comfort around list objects is hugely important as you start to build tooling that interfaces are with other interfaces or other maybe API services or whatnot. And I think that's an important skill to have. So it's great to see the full gamut of R6 and list operations in full display of what Gus has talked about here. So highly recommend taking a spin with this. As long as you have R6 on your system, you can run this code on your system and have fun with it. And we're going to take a slight turn in our next highlight to one of our favorite frameworks to talk about, as always, is the Shiny ecosystem. I am always developing something with Shiny these days, whether it's releasing a production app or seeing what LLM kind of chaos will happen when I boot up a new app from scratch. Had some fun stuff with that at a conference recently. But there is in the latest Shiny ecosystem, one of the packages, the UI toolkits that we've been using a lot in the internal apps we develop is bslib. bslib has really changed the game for us on building really attractive applications without much effort. But when we want to customize it, there's a great way to do that. So a lot of people out there are building dashboards with this, and there are some certain utilities in bslib that I've been making heavy use of that just got a major upgrade. And so we're talking about this latest blog post that talks about the new feature called Toolbars that can help you supercharge your cards with inputs and other nice enhancements. And this is coming to us from the Posit blog, by the open source blog at Posit by Liz Nelson, a senior software engineer at Posit. And she motivates this situation. Like I said, you're building a dashboard. You've got maybe an AI chat. You've got these cards that have, various outputs in there. And then, but you've got maybe a scattering of inputs, buttons and whatnot. And sometimes space is a premium. You just wish you had another place to put them. Well, you do now, because in the latest versions of bslib and Shiny, you can now use toolbars inside the cards. Cards are a very nice UI framework in bslib to kind of separate out different sections of your app. You have a nice heading there. You can put other, tab cards in there, go through different outputs or different inputs. But in this case, you've got now other things you can put in there. So there is an example, first one to clarify. bslib on the R side has this as a version 0.11, but also Shiny itself in Python has this as a version 1.6. So, once you have those, you're ready to try this out. So there is a basic app that they walk through. There's a screencast of the app in action in the blog post. You got some cards, some data looking and some filtering. And you have a starting point, not much here. But for a toolbar, all you have to do is use the function toolbar to start with, and you can give it an align option, but that's just in an empty place. Obviously, you're going to put this somewhere. So you can put this in the card header, say right aligned, such as the first example where you've got the sales data, and then there is a toolbar in the upper right corner that lets the user do a filter. You can have the choice of all for all the records, or in this case, different regions, such as north, south, east, or west, and let the user hit that button and be able to do it right there. And you can also even have, if you really want to get fancy, a save button as well that could do some other, lower level operation. Maybe you don't want it in the header. You can put it in the footer as well. Again, you can just put it in card footer, in this case, the toolbar call, and see that in action. And so toolbars itself have select inputs capable and buttons as well. They come out of the box of update functions. So if you want to update a server side, you can absolutely do that. And speaking of which, how would you update a toolbar button? You can do that with the update toolbar input button. That's a long function, but you can easily do that. If you want to, say, change the button like symbol from that save to show that like it's done a save or something like that, you can absolutely do that. You can also attach different controls or different elements inside an input itself, such as in this next example, having a text input for, say, quantity. You can just type it in, but you could have a toolbar in this input label that lets the user quickly select, say, 10, 50, or 100 as a convenient way, or to reset it to a default state. Boy, oh boy, now my ideas are really starting to turn here, and I can see some enhancements I'm about to make here. Other things you can do here that I think are very interesting. You can augment this with, say, a chat interface that you do with, say, Shiny Chat or whatnot, and you can put toolbars in that area, such as having an input box select area and whatnot. So there's a lot more you can do here. We just scratched a few examples here. I think this could be a huge win for usability as you start to have these different sections of your app, but you don't always want to have that button right below it or that other navigation area right below it. You can use the real estate pretty effectively. So I've got some ideas churning now, Mike, to enhance my apps in the future. And these cards I have all over my app with some nice functionality with toolbars.
I'm ready to rewrite just about every Shiny app that we have to leverage toolbars. This is nothing short of awesome. It's tricky for us to do it justice on a podcast.
Right.
I think that you got to go to the rweekly.org and take a look at the blog post here from Posit. Exciting that we have this out both on the R side and the Python side as well. This component is fantastic, and there's so many little use cases. We used to use something out of the Shiny Widgets package. I think that gave us a little gear icon where we could store
I remember that.
all of our inputs in sort of a much more confined space that you could toggle as open or close, and it worked well, but the UX here is just nicer. I mean, there's no other way to say it. This is absolutely beautiful, and there's more things that you can do. It's fantastic. So I'm super excited about this, kind of reflecting at a higher level. I've seen on LinkedIn lately in the last week or two, Tarif Kouaf, who is the president of Posit, talking about the mission of Posit and everything that they're doing and their PBC status and stuff like that. And the fact that we get this stuff in the open source, virtually for free, it's incredible. It's awesome. I love the community. Really appreciative of what the Posit team does on both the open source side and the other side of their business that supports the open source side. So this is mind-blowing, and I am super, super excited to get this in all of our Shiny apps, past and present and future.
Yeah, and there's something to be said, and as you alluded to, I have used many of the ecosystem of Shiny packages in previous versions of my apps, such as, say, BS4 Dash and, like I said, Shiny Widgets. Very powerful, lots of great utilities. Depending on your use case, there comes a time where you do want to kind of minimize how much you have to tap into as far as dependencies and, other, sometimes packages have their own DSL as well. So, yeah, I know there is such a thing that some people are concerned about a package being maybe too big for its own good. But in this case, having functionality like this in bslib on the R side, it just gives us additional possibilities. But knowing that there is significant testing, significant rigor behind developing these, they don't rush these features either. bslib, like many of the packages that the Shiny team produces, have a deliberate, purpose, set of cadence, you might say, to rolling out these features. And I definitely think in the age where I think more people are going to be developing Shiny apps with a little help from it's great to have these things kind of ready to go so that once you get that initial bootstrap of an app, you can now enhance it very easily using the same way that it's been built. So I like you, Mike, I can think of 1 or 2 apps I've literally just put in production in the last month that in my next point release, I'm going to move some things from one side and put in a toolbar in another because my users will really appreciate that. And rounding out our highlights today, we're going to stay with the Posit team in our next highlight here, but we're going to be diving into the world of high performance computing. And, you know, we talk about the concept of memory a lot in many different aspects these days, one of which definitely being on the LLM side, but this can also apply to batch processing as well for asynchronous work. And that's where our next highlight here, our last highlight, I should say, comes to us from the Posit dev blog once again, the open source blog. And Charlie Gao, who is one of the software engineers at Posit, author of the very amazing Mirai package. And what he talks about now is the unique combination of the latest version of Mirai and a new release of the Mori package. You may not know what this is all about, but let's motivate the issue here. I have had many, and I do mean many, HPC job submissions in my day job over the course of my career. And one thing that has always bugged me was when I have to share some kind of state between the jobs, which often ended up with me either writing out objects from one job and then having other jobs consume it, doing that all manually, or sending the same object to each of them individually. There are lots of gotchas with that. It's a lot of bookkeeping you have to keep up with. And it can also mean a lot of duplicated effort, a lot of duplicated data to be exact. And you might eventually get to a point where you've crammed all the memory in those job processes, and then you get the epic fail, and then you see that job killed, and you're like, oh boy, I got to do it all over again. Well, these are the kind of issues that I think this next combination of Mirai and Mori are going to help you with the idea of shared memory across multiple processes. So Mirai itself, we've talked about many times on the show, it is one of the first in class frameworks for asynchronous programming in R. It's got plugins or extensibility to many different frameworks for HPC type of submission. But as far as the memory involved in these, there's not been a real built-in way to do this, especially in the base R installation. And no real way, I should say, to share these different data or objects without duplicating it as a full copy. So now, with the Mirai 2.7 that was just released, you can have now a bounded queue, as they say, built into how the processes are dispatched. So it gives you a little extra stability here that is non-blocking with this constraint. But then Mori brings another stable part in this, and that is the shared memory format. So when in Mirai itself, you can launch these processes with the daemons function, but inside of it now, you can supply a memory argument. That is one way to cap how much memory is going to be used by the overall processes. Your HPC admins may thank you for this if you're using this on an HPC cluster. Don't ask me why I know. But there are other niceties that you can see on top of just minimizing the memory footprint, and that is being able to share what is happening or what is actually shared with this. That's where Mori comes in. Mori has a function called share that will write, say, an object, and there are different object types supported here, into a level of shared memory that the operating system itself understands. We're not talking about just R here. We're talking about the actual operating system. And from an innovation in base R from a few years ago, it leverages the alt rep, which stands for alternative representation wrapper, so that all these processes on this same OS that you're launching these HPC jobs on, they can map to the same shared memory area, no copying. It's only grabbing what it needs. And the R itself can manage the garbage collection of this without any problem. And this was experimented with in a previous version of mori, but now it's out of experimental status as a version 0.2. So in the example here, Charlie makes a object LST with this share function call, which has a list of random numbers for like weights and targets and inputs and whatnot. And then if you inspect this shared name, use the shared name method or function on this LST object, you will see literally it looks like a file path of where these objects are stored. And then this object can now be passed directly into the daemon from mirai as one of the things you supply to it. And you can consume that as well in a separate session with the map shared function, giving it the address of where that allocation happened to be. And it's got that path syntax to the object name. So again, this is hugely important to help bring asynchronous programming in R to somewhat equal footing on how some other frameworks for asynchronous programming in the other languages are handling it. So he concludes his post at comparing it to these other frameworks. So this idea of kind of constraining the memory is similar to what in the Python world async io.q and from Ray's max pending task. I never used these before, but it's first in class what Mori is doing here. Also, the non-blocking submission aspect, when you have a full queue ahead of you, that's also mirroring a framework called Tokyo's try send. And then this zero copying of the memory share, that also is similar to what the Ray framework is called Plasma Object Store. But this is very, very interesting here. I wish I had this about 8 years ago, but hey, I digress. I would have made my HPC admins much more happy. So next time you're putting Mirai in production, you may want to give this updated version a spin, because this might save you a boatload of effort as well as saving on resources to get those jobs done. So Mirai, that development's not stopping anytime soon, and it's awesome to see Charlie enhance these frameworks with even more powerful features to make asynchronous programming in R a real breeze these days.
This is pretty incredible, and I think the things that Charlie has done with Mirai in the last couple years, I don't even know if it has been that long, have been really incredible. We don't do a whole lot of HPC type of work. That's not necessarily my background, and we just don't run into it too often, but I know it's big in the life sciences. And for so many years, we had future and promises, right?
Yep.
And they worked pretty well when they worked, I guess, but sometimes they didn't. And one thing that has sort of struck me in taking a look at what Mirai has been able to accomplish in the last couple years is really its sort of durability. It just seems like Charlie has maybe built a better mousetrap here in terms of going back to the drawing board, reassessing, especially in terms of dependencies, what's necessary for doing this asynchronous programming. And it's one thing to kick off multiple processes asynchronously, but it's another thing to get them to talk to each other.
Yes.
That is wild. So this sort of combination of Mirai and Mori being able to work together here and share this memory back and forth is phenomenal. And I have to imagine for the HPC community, it has the potential to really speed up pipelines, which we hope would be able to speed up real outcomes for real people in the real world, right?
You're exactly right. You're exactly right. Yep. My head is spinning right now, Mike, because
took a deep breath there. I got worried.
Yeah, no, it's because the app I've had in production the longest, that is my first attempt at putting Shiny as a front end for HPC stuff. it does the job. It literally, I still remember the day I was working late one day at the office, and I got it to work the first time. I jumped out of my chair. I was like, that was like the biggest victory, dead victory I had in my first 5 years of working there. But it does things kind of inefficiently. It does pass a lot of stuff by copying, and then it's a pretty time consuming process. And yeah, there are times where the memory does get maxed out. I really need to refactor to mirai with this, because it could literally cut the execution time probably by half, and also play nicely on our grid so that I could potentially have more jobs spun up in parallel instead of smaller number of jobs, but they all do more. Like, it gives me that flexibility I didn't think was possible. So Charlie, I don't know how you do it, man. But man, if I see you at PosiConf later in the year, I'm going to shake your hand once again, because this is just amazing stuff that I think is going to supercharge my HPC workflows.
Incredible work.
Absolutely. And the rest of the issue at our weekly, whether you like what we just geeked out about with HPC and async or the Shiny, frame ecosystem, there's a lot more to choose from here. Where can you find it? Mike told you already, but I'm going to tell you again. It's at ourweekly.org. That's where you'll find the latest issue link there. We are running a bit low on time, so we won't talk about the additional finds, but I'm already looking at the issue in front of me. There's some really interesting stuff here about energy usage, the latest updates from our OpenSci, and much, much more. And we, of course, this effort, which I will talk about at PosiConf later in the year, is very much a community effort. We need your help. We want to see what that great resource is that you found, that great package you developed, or somebody else developed that you want the world to know about. We're a pull request away, all on GitHub, all freely available. If you know Markdown, you can give us a pull request. It is just that easy. Trademark. But once you go to ourweekly.org, upper right corner, you can get taken directly to the pull request template for our issue draft and send us that great resource. And we want to hear from you as well in your adventures, whether you're building awesome Shiny apps, you're launching all sorts of HPC submissions, or anywhere in between. You can find me on the various social medias out there. I am on Blue Sky with @ourpodcast at bsky.social. I'm also on Mastodon. I'm at ourpodcast at podcastindex.social. And I'm on LinkedIn. Just search my name and you'll find me out there. One little mini shout out to my friends at Jupiter Broadcasting, who I had teased earlier, telling them I was going to try something different for my podcast production workflow. So if this episode does go out, mission accomplished, and thank you all for the help. But Mike, where can the listeners find you?
You can find me on Blue Sky at Mike-Thomas at bsky.social, or on LinkedIn if you search Ketchbrook Analytics, KETCHBROOK. You can see what I'm up to.
Yep, and Mike's been blogging again, so I'm going to put a link to his latest blog post in the show notes. It was very insightful, and as I alluded to in one of the comments I put on there, a lot of people need to read it. Maybe give the listeners, Mike, a little teaser what you put out there.
Sure. Well, I did submit it to R Weekly. I'm not sure if it's R related enough to actually land there, but maybe you'll see it on the website next week. And it is really a discussion and some reflections on how our investments at Ketchbrook in terms of securing Claude Code have just made me be able to sleep at night, and also allowed us to just run faster and get stuff done without necessarily needing to worry about some environment variables or secrets getting exposed to Claude Code or proprietary information or anything like that. We have it pretty well sandboxed and locked down, which just allows us to not have to worry about those things on a day-to-day basis.
Yes, and I know I'm in one industry that needs to see that message, and we are trying efforts, and others as well. So yeah, use this stuff responsibly. It's quite powerful, but you don't want to be that next person that accidentally deleted a database in production because of an LLM call. If you know, you know. In any event, I'll close up shop for episode 229 of our weekly highlights. We're so happy that you joined us for this episode, and we hope to have you back joining us for the next episode of our weekly highlights, which will drop next week.